Hey guys, this is lesson 14, exploring the meaning of zero and negative exponents. Okay, so how we're going to learn about this is we're just going to look at this chart that goes from 10 with an exponent of 4 all the way to 10 with an exponent of negative 3. Okay, and we'll see what we're looking at here. So if we were to write 10 to the power 4 in expanded form, this is just 10 times 10 times 10 times 10, which if you were to multiply those, so we can use our calculator, right? 10 exponent 4, and it would be 10,000, right? So 10,000 is our standard form. Okay. Then our next one is 10 to the power of 3, which is 10 times 10 times 10. All right, now we only have 3 10s multiplying. Okay, so we're going to have 10 times 10 times 10 is going to be 1,000 now. Okay, then we keep going. 10 to the power of 2 is 10 times 10, which is 100. And then 10 to the power of 1 is just 110. So we just have 10 would be our standard form. Okay. And then the next one is 10 to the power of 0. So 10 to the power of 0 is a bit of a weird one. But we can explore first by just typing into our calculator. 10 to the exponent of 0 is 1. Okay, let's have a look at this. So you can see, so we know right away this is going to be 1. That 1 is going to be the expanded form, and it's also going to be the standard form. Okay. And the one way to make sense of this is that when we go from 10,000 to 1,000, we divided by 10. We went from 1,000 to 100, we divided by 10. When we went from 100 to 10, we divided by 10. And now we're just continuing that same pattern, okay? So 10 divided by 10, 10 divided by 10 is 1. So that's why if we continue this pattern of the exponents going down, 10 to the power of 0 is 1, because as our exponents go down by 1, we're really just dividing by 10 each time, okay? And basically you'll find that anything, this doesn't have to be 10, anything to the power of 0 is going to be 1, okay? Because anything to the power of 1 is itself, and then if you take whatever number it is and divide it by itself, it will always be 1, okay? So that's 0 exponents, so that's part of what we're learning today, is that anything to the exponent of 0 is just going to be 1, okay? And now we're going to get into the negative exponent part. Now, it's really hard to make sense of 10 to the negative 1, like what does it actually look like? But there's patterns in math, and if we just continue this pattern again, okay? If we continue this pattern again and divide by 10, we want to think, so what is 1 divided by 10? 1 divided by 10 is 0.1, okay? So this next one is going to be 0.1. Or you could leave it as a fraction 1 over 10. Okay. So in expanded form, it's really just 1 over 10. Okay. And then again, if we multiply this by 10 again, or sorry, divide by 10 again. If we divide by 10 again, we have 0.1 divided by 10. And now it's 0.01. Okay, so now it's 0.01. And as a fraction, 0.01 is 1 over 100. So what's going on here for expanded form is, so remember with positive exponents, we started with a bunch of 10s being multiplied. We got smaller and smaller, eventually got to 1. Now we have 1 over 10, because it's just to the negative 1. This next one in expanded form is actually going to be 1 over 10 times 1 over 10. Because if 10 to the power of negative 1 is 1 over 10, then 10 to the power of negative 2 is 1 over 10 times itself twice. Okay? And you can imagine that this pattern just keeps going. When we have 10 to the negative 3, we have 1 over 10 times 1 over 10 times 1 over 10. Okay? And when we do that, we get... When we do that, we get 0.001 or 1 over 1,000. Okay? And again, this is continuing the pattern of dividing by 10 each time. And this is what's going on. So you can see when you have a negative exponent, you end up getting a fraction. So this question says, what do you think a negative exponent means? And how we can make sense of this a little bit is we can say it means that we are dividing by the base with the positive exponent. Okay, dividing by the base with the positive exponent. And what I mean by this is basically if we have 10 to the power of negative 2, so 10 to the power of negative 2, what we're really doing is just taking 1 and dividing it by 10 to the exponent of positive 2, right? Because 10 to the exponent of positive 2 is 1 over 100, which is exactly what we got when we multiplied 1 times 10 times 1 times 10. It was 1 over 100. Okay? So this is sort of the important thing you want to realize is that whenever you have a negative exponent, you're going to be dividing what this is, but with a positive exponent by 1 divided by this with a positive exponent. Okay? And then 10 squared is just 100, so that's why we can simplify it to this. Okay. Okay, so now when we get into dividing these, let's write this out in expanded form. So basically we have on top 2 times 2 times 2. Okay. And then we're dividing that by 5 2's being multiplied, right? 2 times 2 times 2 times 2 times 2. Okay. When we simplify this, basically, because 2 divided by 2 is just 1, we can think of this canceling, 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 right? 1 for 1, we're canceling. And then we're left with, on top, there's no 2's left, so we just imagine it's a 1 up there, okay? And it's 1 divided by 2 times 2, which is 4. Okay, so if we simplify this, we get 1 over 4. And if we were to write this with a 0 or negative exponent, so our base would stay the same, so our base would still be 2. Okay. And then 4 is the same as 1 over 2 squared, right? We have 2 2's being multiplied, so that's the same as 2 squared. Okay, and because we're dividing by 2 squared, our original exponent should be 2 to the negative 2. Okay, so if we were to write this expression with a negative exponent, this is what we get. And this also makes sense because if we do our exponent rules we learned last unit, when we're dividing powers, we subtract exponents. So we would do 2 to the power of 3 minus 5, which is 2 to the negative 2. Okay, which is exactly what we got over here, 2 to the negative 2. Okay, let's continue on. So doing this one in expanded form, we have 5 3's being multiplied on top. This time I'm just going to put them all in brackets. 3 times 3 times 3 times 3 times 3. So that's 5 of them, and we're dividing by 8 of them. So 1, 2, 3, 4, 5, 6, 7, 8. And these are all being multiplied. Okay, again, pause the video and go back if you need to. But I'm going to continue on. So when we're canceling out these 3's, it's just 1 for 1. So this one cancels with this one, this one, this one, and so on. And then finally, we have 3 3's in the bottom. So what this really is it's 1 over 3 to the power of 3, right? Because there's 3 of them. Which would also equal 1 over 3 to the power of 3 is 27. Okay. But if you want to write this as a negative exponent, we take what we're dividing by here, and then we make the exponent negative. So it's 3 to the negative 3. Okay. Again, if you want to think of exponent rules right from the start, our base would stay the same. We'd do 5 minus 8, which is negative 3. Okay, so that's where the negative 3 comes from, 3 to the negative 3. Okay. Okay, next couple, these are all very similar. So now we have 2 10s, 10 times 10, and we're dividing by 6 10s. So 1, 2, 3, 4, 5, 6. These are all being multiplied. Okay. So this 10 cancels with this 10, this 10 cancels with this 10, and we're left with 1 on top over 10 to the power of, we have 1, 2, 3, 4 10s left. Okay. 10 to the power of 4 we know is 10,000. So this would be 1 over 10,000. Okay. But just remember, if you want to write this with a negative exponent, you're just taking the exponent on the bottom and making it negative. So we have 10 to the negative 4. Okay. And we can double check that answer by looking here. So base would be the same. 2 minus 6 is negative 4. So we get 10 to the negative 4 both ways. Okay. Now, 7 to the 3 divided by 7 to the 3. So we have 7 times 7 times 7 over 7 times 7 times 7. Okay. And remember, when we're canceling these things out, we're canceling them out because they equal 1. So 7 and 7 divided by 7 equals 1. 7 divided by 7 equals 1. 7 divided by 7 equals 1. So there's nothing left here except for 1. Because when you divide this, you just get 1. So our simplified version here is just 1. Okay. Which is the same as doing 7 to the power of 0. Okay, because 7 to the power of 0, anything to the power of 0 with an exponent of 0 is 1. Okay. If you think about exponent rules here, our base stays the same. 3 minus 3 is 0. So that's how we get 7 to the exponent of 0. Okay. So that was kind of showing you how we get these things, or trying to make sense of negative exponents and 0 exponents. On the next page here, we're just going to focus on actual examples, sort of like you might see on a test or a quiz. Okay. And this gives our official exponent rules as well. This page. Okay. So our official exponent rule. So one of them is the zero exponent rule, and it says that any number to the exponent of 0 is equal to 1. Okay? So this is sort of the formula here. So a to the 0 equals 1, no matter what a is. Okay? So 25 to the 0 is going to be 1. Negative 25 in brackets to the 0 is going to be 1. And negative 25 to the 0, this is where we have to be careful, okay? So in this case, the 0 was applying to the entire thing, the whole negative 25, which makes the whole thing 1, okay? Here, because it's not in brackets, you have to think that this 0 is only applying on the 25 and not on the negative. So the negative still needs to be there. And then 25 to the exponent of 0 is 1. So that's why this answer actually ends up being negative 1 instead of 1 like this one. Okay, so just be careful of the difference here. This one's in brackets, so it becomes 1. This one's not in brackets, so the negative sign has to stay. And the 25 to the exponent of 0 is just 1. Okay? Okay. So next is our negative exponent rule. Okay, it says when a natural number is raised to a negative exponent, it indicates that the base belongs in the denominator. The result will be a fraction with a decimal value between 0 and 1. A negative exponent does not mean the value will be a negative number. Yes, that's very important. Just because you have a negative exponent does not mean it's going to be a negative answer. Okay? Okay. So this is your official sort of formula. So anything with a negative exponent, you're going to put it in the denominator and you're going to make the exponent positive. Okay? So as an example, 5 to the negative 3, we put this in the denominator, so 1 divided by this, but we make the exponent positive. This is the same as 1 divided by 5 times 5 times 5, which is the same as 1 divided by 125. Okay? You don't have to show this step every time, but you should show this step and this step. Okay? So let's take a look at some examples here. First one. So negative exponent. Right away we're going to do 1 divided by this, but with a positive exponent. So 1 divided by 7 squared, we get rid of the negative when we put it in the denominator. And then we do the actual exponent. So this will be 1 divided by 7 squared is 49. And that's our answer. Okay? Again, you have to show the step. You can't just put this in your calculator or I'll mark it wrong, okay? You have to show me the step. Okay, next one. This is a negative exponent, so we need to put it in the denominator. That'll make it positive. And then 5 to the exponent of 1 is still just 1 over 5, and that would be our answer. Okay. Next one. Because we have a negative exponent, it needs to go in the denominator, and the exponent becomes positive. And then in our calculator, we can do 2 exponent 3, and you should get 8. So our answer would be 1 over 8. Okay? Negative exponents, these are all sort of the same thing, okay? So 1 over 5 with a positive 4 exponent. Okay, and this one I need a calculator for. So 5 exponent 4 is 625. So this is 1 over 625. And that's our final answer. Okay? So now we're going to throw negative exponents into the other exponent rules we learned. Okay? So example E here. So if here we're multiplying powers, so remember we have to add exponents. And I'm going to show you the step here. So we keep the base the same, and we're adding exponents. So it's 4 plus negative 7. Okay? 4 plus negative 7 is the same thing as 4 minus 7, which is negative 3. Okay. Once we get here, we now have something like this one, right? So we're going to put it in the denominator, make the exponent positive, and then we'll get our final answer by doing 2 to the power of 3, which is 8. So our answer is 1 over 8. Okay. Next one, we're dividing two powers. Remember, when we're dividing powers, we subtract exponents. So we leave the base the same, and it's 2 minus 4. So 2 minus 4. Okay. So we have 6. 2 minus 4 is negative 2. Okay. Now, because we have a negative exponent, we need to put it in the denominator and make the exponent positive. And then we know that 6 squared is 36, so we have 1 over 36. Okay. Again, I'm going kind of quick here, but these are exponent rules we've done before, and you can pause the video at any time, okay? Okay. This one, again, we're dividing two powers, so we need to subtract exponents. So we have 8, 10 minus 13. Okay, base stays the same as 8, and then we do 10 minus 13, which is negative 3. To make this exponent positive, we need to put it in the denominator, and then we do the 1 over 8 exponent 3. 8 exponent 3 is 512. Okay, so it's 1 over 512, and that is our final answer. Okay, last one. This one has 3 steps to it. So first, we need to multiply powers, which means we add exponents, okay? So we have 2, and then negative 4 plus 7 is 3. And then we're still dividing by 2 over 6. Or sorry, 2 exponent 6. Okay. Now we're dividing powers, so we need to subtract the exponents. So base stays the same as 2, and then we do 3 minus 6, which is negative 3. Okay, and we've done 2 to the negative 3 a few times now. We know 2 to the negative 3 is just 1 over 8, so this is going to be 1 over 8. Okay, and that is it for that one. Okay, last example here, a little bit of a word problem. It says Christina and Michelle are working on the following check your understanding question. The value of 6 to the negative 1 is, and it has 4 options. Christina thinks the answer is C. Michelle thinks the answer is A. Is either of them correct, and how do you know? So let's start by just doing what we know here. So 6 to the negative 1. So we know we have to put this in the denominator to make the fraction, or to make the exponent positive. So we have 1 over 6, and that would make the exponent positive 1. And we know that 6 to the power of 1 is just 6. So our answer should be 1 over 6 here. Okay. So let's take a look. Christina thinks C. Okay, Christina thinks C. And Michelle thinks A. Okay. So we know Christina is correct, because that's what we got down here, okay? So we know Christina is correct. And we should explain why Michelle is not correct, okay? So Christina is correct. It is 1 over 6. And we showed our steps here, okay? And then to explain why Michelle is not correct, notice she saw there's a negative exponent, so she just made this negative 6, okay? But remember what we talked about up here, a negative exponent does not mean that the value will be a negative number, okay? So we can say Michelle is incorrect. Negative exponent does not make the base, so remember the base is 6 here, does not make the base a negative number. Okay. That is all for today. So you guys are working on the practice on the next side. Make sure you're checking your solutions and asking questions if you have them. Have fun.